Hello, everyone. I'm really happy that so many people found the topic interesting. It's a bit intimidating because it's also my first talk at the PyData conference. But anyway, yeah. A long time ago, about 6 months actually, in an office far away on Alexanderplatz, which from here is actually kind of far. My team and I, we had a problem because we found ourselves in a situation where we had to implement machine learning research papers. How many of you can relate to this problem? So how many of you have either in uni or in work tried to implement machine learning papers? That's a lot of people. And how many of you found that process somewhat frustrating or annoying or a bit confusing? Keep your hands up. That's still a lot of people. So my background is actually less in machine learning, and it used to be more data engineering and analytics. And so for a long time, I've avoided looking into machine learning research paper. I always thought they would be filled with really unpractical formulas and very impractical suggestions. But then work is all about growth, right? So eventually you have to do even the things that you find scary. And fortunately, I was not alone. Some of my colleagues from that time are actually here in that room. And we all had worked with research sometime in our time at uni, writing theses, writing journal papers, whatever. And so we pooled all of our knowledge together about how to approach this problem. And our use case is what's called page stream separation. So we found ourselves in a situation that we wanted to classify documents. And we found ourselves with a situation where we were able to classify the documents pretty reliably. But on the other hand, we also wanted to break the multi-document PDFs into separate documents. So you have a stream of pages, and you want to figure out which of them is the ID, which one is the income statement, which one is the contract. And this is one of the papers we use. I'll refer to this paper a few times in the talk. But then, of course, the question is, when should you actually bother with implementing machine learning papers? And the one condition in my mind that really needs to be hit is you have this idea, it's not something that nobody has ever tried before. Somebody else must have solved this issue before. But then, on the other hand, while somebody might have solved the problem, nobody has ever made a ready-made implementation, something that you can take and go and either buy or just install. And so then you find yourself with somebody hopefully wrote down what they did, but in the form of a research paper, but nobody ever implemented it. And that's exactly the situation we found ourselves. And we found a lot of tooling to help us with classifying documents, but nothing to separate the stream of documents into separate documents. And so then, pooling all our knowledge together, this is the kind of a cleaned up version of the process we came up with and followed. And to give a bit of a spoiler to my issue I had in the beginning, it actually wasn't as bad as I thought. It was actually in many places quite enjoyable. And so I hope that for those of you that did find the experience frustrating before, that following such a similar process might make it a bit easier, and then you can focus more on the details of what you're doing and less on organizing your workflow. And the first step in this workflow is to look for research finding. That's the obvious starting point, because you need to start with something. Then once you have a pile of papers, or at least a list of papers or something, figure out which ones are the right for you based on the criteria. And so in this step, you just define which criteria make a good paper for you. And then the core of the process is evaluating the papers and figuring out which paper, based on the criteria you have, is the best one. And then after you have the list of papers that you find relevant to your own problem, prioritize them, obviously, to figure out which one to start with. And only the last step is actually the actual building a prototype. And for the rest of my talk, I want to describe those steps in a bit more detail. So the first step. So when you look into the problem we had, which is page segmentation, you get about 2 million hits in Google Scholar, which is obviously not something that you would ever want to look at in all detail, in its all comprehensiveness. So what we had to do is build some kind of map of the universe, or of the amount of papers in this area, and figure out which of the ones are right for us. And You may remember if you wrote a thesis in uni or something, or a research paper, it's a similar problem actually. And probably your advisor gave you the idea to compile an overview of the field. This may even have been your only assignment if it was a seminar paper. And then you find the best way to usually start with those is somebody has already compiled at least a part of the research universe for you. Usually not completely, but there are papers that summarize a lot of related research in the field. And if you find a few of those, or maybe you even find a textbook chapter if you're really lucky, you can follow the references of those papers. And then there are two things that are really interesting to look at as you build your understanding of the field, and to figure out which is the main meat of the areas. One is to figure out what are the common problems that people are facing, so what are they actually working on and why are they working on these, and which are the top approaches that people use, so that when you look into a paper, you don't start with something that turns out to be really random, but something that's really a major approach. And the papers that are usually interesting are those that are either foundational, or which means they started a new approach and found a different way to solve the problem that you're facing, or they are cutting edge, which means they took an existing approach and they're really new and had a new approach to the issue. So now that we built this kind of map, and we have a hopefully somewhat commented list of research papers that we want to look at, the next question is, as I said, how do we compare them? And that's where really involves a lot of your own creativity. Because here you're tailoring your analysis to the specific problem that you're facing, as opposed to whoever else wrote the survey papers. And what we did, and what turned out to be really helpful, is first to summarize the common metrics that other people have used to address this, to evaluate models for the same problem, to summarize metrics and also find some baselines to compare against, and then pick some simple ones that are easy to evaluate, both metrics and baselines. And for the metrics, it's also really important to be clear about what's the minimum level that you need to achieve in your problem for it to actually make sense in your context. Maybe that's 70% if you're happy with a really vague answer, but maybe it's 99.9%. And that makes a big difference about which papers you can actually evaluate or not. And there's a link here which will have some really interesting explanations about how baselines work. If you want a bit of a refresher, I can recommend that the slides will be available later, so you can check the links if you want. And now that we know what defines a good paper for us, the question is, of course, how do we find the papers that actually are good for us? And there's a blog article which addresses a similar issue to my talk, which I also link later in my slides. And he defines 3 different kinds of papers that make up the universe of written papers. And he says one of them is the groundbreaking papers, those which are like the foundational papers I referenced earlier, which define a new approach to solving the problem that you're facing. Then there's what he calls copycat papers, which I think is a bit of a mean name, but he's pretty negative about them. Those are papers that take an existing approach and try to improve it. I think that's actually a nice thing, but his argument is that they often complicate the approach more than necessary, which is something to consider. So the copycat papers, they try to improve the approach, and they either succeed or not, but sometimes they also simplify the existing foundational paper. And then, unfortunately, as you probably all have seen, there are papers that were just published for the sake of publishing, which don't really contribute anything to the research landscape. And now, of course, the question is, how do you find out which papers actually are good for the purpose that you want to solve? And there are some obvious pointers, like the journal and the conference quality. If you can evaluate it, that's usually a good indicator. And also, if you look a bit into the teams, if you have time to go there, you can see how much the research team has actually worked with that issue, whether it's a one-off paper for them, or whether they have spent 20 years researching that particular problem. And to go a bit deeper into those 2 pointers, I've developed a checklist of based on the different sections that are usually in a paper, at least the ones that are particularly interesting in the evaluation phase. And I want to now present you the checklist about what to watch out for in a research paper to find out whether it's a good paper that you want to prototype or not. And the first section that's always interesting to check is the abstract and the introduction. It's usually pretty short, so it's not a lot of time invested. And the main question here is this paper at all relevant to your problem? And there are different questions you can ask yourself. The first one being, does it address your problem at all, or is it about something totally different? That's kind of obvious. But a bit more subtle is the question, does it address your problem in a similar context? So for example, we have here, in this paper, we have the problem is to separate a stream of scanned image in a multi-page document. This is exactly the problem we had, so in that sense, the paper is probably very relevant. And the context is digital mailrooms or retro-digitalization of late paper artifacts. Digital mailrooms is a bit related to what we're doing, not quite, but the other context is pretty different. So it's a bit of a question mark whether the paper, even though they have a similar problem, whether we can really transfer the insights from the paper. And then, of course, there are questions about the approach. Again, is it a groundbreaking one or is it an improvement? And of course, looking at the results, are they better than the metrics, targets, and the baselines that you defined for yourself? So if it's worth even looking deeper. And once you decide that you want to look deeper, and in this case we decided to look deeper into this paper, the next question is the approach reproducible at all? So will you be able to get the results from the paper that they claim to have? And the first question there is the data set size and content. So will you be able to transfer from the data they use the algorithm and take the same algorithm and apply it to your own use case? And going back to the example paper, the context and the data set size was reasonably similar for us. So they also had about 20,000 black and white pages, which was what we also had. Well, we had a few bit more pages, but it was in the same ballpark. And the corpus is a German language, which is rare in a research paper and was definitely very helpful to us. But the context, as I said, was different. So they used research documents, which have a different structure than the banking documents that we were dealing with. But still, it was still worth considering. Then the next big question is, do they describe the entire process? If they miss steps and only talk about the things that they found academically interesting, then the paper is really hard to reproduce. It might be interesting from a scientific context, but definitely not easy to implement. And especially in this context, what people like to admit is pre-processing, even though that's really important if you want to reproduce a paper. So in our paper, they seem to have described the entire process as far as we could tell. And in the pre-processing steps, they gave some information which helped us to get the data into the right shapes, but it wasn't quite complete. So they did describe the image conversion and the scaling, so how they dealt with the pages and images. But they had a multi-approach, which was both based on images and on text. And for the text, they used OCR, and they just said they used OCR. Now, fortunately, OCR these days is pretty standard, so we decided to not be bothered with that too much. But it's still a question mark, because we might get very different results if, for some reason, our OCR is far worse. And then another big question is, do you understand, can you implement the actual methods? So if they use a certain method, for example, here they use CNNs, do you know what that is? And if you don't know what it is, if it's something pretty obscure, do they describe what it is? And fortunately, in this paper, they did describe what it is. CNN these days is not that obscure. And they also described how they figured their CNNs. So that was a real highlight of this paper. And then, so we decided we can probably reproduce this paper if we wanted. And then we looked at the results section. So, and there the question is, can we trust the results? Are they reliable? Can we be confident that the paper will actually have the results that we were looking for? And the first question here is, what metrics are they using? Are they relevant to our use case? In the paper, they used accuracy, which for a classification problem, as we looked at the page stream separation as a classification problem, is a pretty common one. And so we decided to take that as one of our use case metrics. And also, it's appropriate for the problem because it's a classification problem. It's a pretty common one, as I said. There's a bit more subtle is the question, though, is the metric not just relevant for the problem, like classification, but also for the specific data set? And here, there's a bit of a concern, because when we talk about page stream separation, what we have is very imbalanced classes. So usually you have what happens is you label each page with whether it's a new page, starting a new document or not. And usually you have much more pages that are not starting a new document if you have long documents. Then you have pages that actually start a new thing, so you have really a heavily unbalanced data set. And then accuracy is, as we usually know, is not a really good metrics to start with. They're better ones to look at. So that was a concern, but we continue with the results section. The next question is whether the results are better than the baseline, which we already checked a bit into the introduction. And yeah, we found it's about 0.35 better than our baseline. And we also checked whether it was better than our metrics target. And there we set a metric target of 95%. And they claimed 93%, so it's not quite there, but close enough possibly. But then, because it's a pretty new paper, I think it was published at the time we read it about 6 months ago, nobody had reviewed the paper yet. If somebody has reviewed the paper and found it to be a good paper, that of course saves you a lot of hassle of evaluating it yourself, so that's a strong indicator. But this paper was still too new to tell anything. And then a bit of a subtle point that's easy to forget is when an algorithm claims an improvement over somebody else's approach, the question is, how did they analyze that? How did they draw this conclusion? Did they use comparable metrics? Did they use proper statistical tests to analyze that? And that's something that's easily skipped in papers because it's a bit annoying and it might devaluate a lot of the results. And also in this paper, they didn't do any statistical analysis. And they didn't even compare with approaches that had used the same metrics. So it's unclear whether they really had the improvements that they claimed. And if you want to have some more pointers about how to evaluate a model or look at statistical tests to compare them, here are some more links that you can look up later if you want. So, after this evaluation, which I just performed as an example for one paper, which of course we did for a lot of papers, the question was, we found a bunch of papers that looked still promising. Which ones do we prioritize? So, my colleague Cory was actually sitting here. She remembered this really nice matrix, which is used in project management. And then we sat in our conference room and evaluated all the papers or all the approaches, to be more precise, that we wanted to try on this matrix, which has in one dimension the amount of impact you expect, for which we used how much they claim to improve the metrics that we wanted to improve as a proxy, and also the amount of effort which comes from is this a ready-made solution? Is it something we understand? Is it something we have to learn? Is it something we have to implement entirely from scratch? And then we just sorted all the approaches into this matrix. And what we did then, the traditional recommendation is to start with the quick wins, which ideally have high impact and low effort. Of course, those are fairy tales usually, but what you can do is at least find something that's somewhere in the mid-impact and mid-effort range and start with that rather than something that might be more interesting but a lot more of a hassle to implement. So, coming to that, now we finally had our list of, I think it was around four approaches or 5 approaches that we wanted to prototype. So we were ready to code. Yay, what could possibly go wrong? Of course, a lot of things, and here are a few recommendations I compiled. Some of them we used, some of them I only discovered later, what to take into account when implementing prototypes. And the first recommendation to start early in the process of implementing is to understand what you're doing and to really understand what you're doing. And if you don't understand something, to figure it out and then compile and document somewhere in a glossary what you're implementing. And also likewise make sure that, especially when the notation is weird and it's a lot of odd pseudocode or odd formulas, to understand what each of them mean and make sure they don't have typos or other oddities that will really annoy you later in the process. And then when you're prototyping, it's a really good idea to start with a high-level language. So yes, maybe sometimes your results will be faster in implementation when you start with a low-level language, but at this point you're not even sure what you want to implement. So you just want to optimize for prototyping speed and use something like Python or Julia or MATLAB, Octave or something to prototype rather than jump into C or Java already. And then kind of a trivial but useful thing is to reference when you implement something, which paper you're implementing and which section of it as a code comment. And then some more recommendations. This one we didn't do, and I think it really hurt us. And I found this in this blog post that I'm just about to link, is to, when you start implementing, try to implement your prototype under the same conditions as much as possible as the research paper that you have, using maybe the same data set if it's accessible and exactly the same pre-processing and exactly the same variation of the algorithm. And only if you see that you can reproduce that and get similar results to your research paper, only then to modify it to fit on your own data and your own algorithmic needs. Because what we found, for example, is a lot of the approaches we tried were not as good as the ones that were claimed in the research paper. And it's hard to figure out why this would be the case if you never tried to implement exactly what the researchers did. And then something really small but really useful that also Corey suggested was to compile all the findings in our paper, all the findings we had in an Excel spreadsheet or a Google spreadsheet, just to see for each of the prototypes we tried, and we tried a lot of variations, and there were a lot floating around in a lot of copied Jupyter notebooks, with which metrics did they exactly give which result, so we could actually track in the end and decide which one is right and not have to dig through a whole amount of Jupyter mess to figure out which one was actually good or not. And it's not on my slides, but I did a previous run of this talk at the meetup, and somebody recommended a very simple thing that could be really useful here. If you get stuck, write to the authors of the paper if you can. Often they have email addresses, and sometimes they might even respond, which I think was a really pragmatic and good tip. So this is the blog post that I mentioned several times. It's also here for reference. It's very helpful, especially on the planting section and also in the first step of the research phase. So that was the gist or the main part of my talk. And just to summarize, when would you want to look for a research paper? First of all, it's a problem which you think somebody has solved before. And also a problem which you think somebody has solved before, or you know somebody has solved before, but nobody was kind enough to implement yet. And then that's a good moment to start going. And then when you find yourself in that situation, these are the steps that I would recommend make life a lot easier to follow them in this order. First, to search for the research findings, then decide on the comparison criteria to figure out what makes a good paper for your use case. Then evaluate all the papers that you find relevant to find out which ones are really meeting those criteria. Then prioritize out of those that seem good, which ones are easy to implement and promising. And finally, to prototype the approach. Yeah. And I hope this may help you make your prototyping life a bit easier. The slides, as I said, will be tweeted. I think they'll also end up on the conference page somewhere, so feel free to follow the links. Thank you very much.
Thanks, Alan, for this really nice and interesting and really important talk. So we have some time for questions.
I can say that.
It's for the recording.
How would you face the problems like
sometimes the hyperparameters are not mentioned in a lot of papers. So how would you recommend to tackle that problem?
Probably the best way is to actually, in that case, write to the authors and figure out if they can send them to you. And if not, you can either try or just ignore the paper, because with the there are some ways, of course, to reconstruct the hyperparameters, and you can try that if it's not too. But also, you might just not get very far. I think it falls out on the incomplete algorithm description.
Some more questions?
Thank you for the nice talk. So among the 5 steps, based on your experience, do you have a rough measure between like 0 and 100% time of your times? How did you split all these 5 steps, especially for the first and third step? Because I think that searching and reading papers will also take some time, but prototyping also will need some time. So how do you balance this time?
Yeah. In our experience, the most effort we had to spend was on prototyping, and followed by reading and evaluating the paper. So step 3 and 5 were the most time-consuming, and the other ones, deciding which one the prioritization was the fastest one, and compiling the information in the first step, and deciding on the criteria was somewhere in between. I guess it's the 5th one is the most time-consuming, third, first, and then the 2nd and the 4th one, if you want to really rank them.
Hello, thank you for your talk. I would like to ask what, from your perspective, researchers could do to ease your work.
Sorry?
What researchers or people writing papers can do to ease your work, to make it more easy?
That's a really nice question. I appreciate it. I think the most important thing is really to describe completely what you're doing, and ideally also, if you have an implementation, publish it, and maybe put a link somewhere in the section. That would make a lot of things easier. So ideally, publish something, and if the code, and if you cannot or don't want to publish the code, at least describe completely what you've been doing, so that it's easier to implement on our own.
Somebody else?
Thank you for your talk. I have a small question. I mean, you said that you mentioned that you going to check for reviews of a paper. Where would you do that? I mean, some platforms, or can you maybe comment on that?
Yeah, usually the easiest way I found to find reviews is to search Google Scholar, and they have a set where there's reference papers that use this references paper, and usually the papers that reference the paper, some of them have reviews of the papers.
Hello, thank you. It's a great presentation. I was wondering, during the compiling of all the papers, you mentioned that you will pick up the metrics they use, every information about the paper. Do you have any spreadsheet or any structure to do that? Anything to help you, or how do you, for example, collect the different papers and share it among the colleagues?
Yeah, we had a Google document, and we just put all the papers in there and our comments on them, and that worked okay. There's more fancy versions, like using something like Mendeley, I guess. I don't know which of them are multi-user friendly, but for us, we just used the Google Doc. That was okay.
How big was the percentage of papers that you started to prototype where you could not get the same results that they claim?
I think it was at least 80%, if not more. It was definitely most of them. I don't remember the exact details, but it was really hard to reproduce the details in prototyping.
How much time did the whole process take in total, and what was basically the end result?
Yeah, I left somewhere in the middle of the project. I changed jobs, so I can't say how exactly it ends. Corey is here. She can probably tell you more. She's waving. So when I was there, I think we spent several months, like 2-3 months, and we went up to develop a bunch of prototypes, none of which turned out to be really what we were looking for. So then the team went on and tried some other approaches, which were more promising, I heard.